Hi, everyone. It's Judy Warner. Welcome back to the OnTrack podcast. Today, we'll be joined by Keshav Amla and Tarun Amla. Keshav is the CEO and founder of Avishtech, and Tarun is the co-founder and CTO. Today, we're going to talk about some exciting new simulation software, but don't worry, it's not like your dad's simulation software. They have some exciting things to share. So lean in, enjoy. I'll see you on the other side. Welcome to Altium's OnTrack podcast, where we talk to leaders about PCB design, tackling subjects ranging from schematic capture all the way to the manufacturing floor. I'm your host, Judy Warner. Please listen in every week and subscribe on iTunes, Stitcher, and all your favorite podcast apps. And be sure to check out the show notes at altium.com/podcast, where you can find great resources and multiple ways to connect with us on social media. Well, hello, Keshav and Tarun. Thank you so much for joining us today.
Thank you, Judy.
Thanks, Judy.
So I was really excited to see Avishtech pop up recently. And so for the sake of our audience, would you please introduce, Keshav, we'll start with you, introduce yourself, and then tell us, one or both of you could tell us a little bit about Avishtech.
Sure. So I'm Keshav Amla, and I started Avishtech with my father, Tarun Amla. We co-founded it in 2015. I had just completed my undergrad at Caltech in mechanical engineering, and I came to Stanford to pursue my graduate work. So I started in my master's in material science and engineering at that time. And so this was going to serve as the vehicle in which we'd do some of the innovations that we had in mind. Initially, we started with some ideas on autonomous driving and pursued IP on that, which we've since obtained. But as time went on, I started to focus on, in my graduate work, I went on to focus on my PhD. So I started a PhD program in mechanical engineering, and I pursued that for some time until around June of 2019, when we got together and really saw this prime opportunity for us to do something fundamentally new in the EDA sector. And when we got together on that, that's when I realized that this was going to require my full-time effort. This was something that we really needed to go all in for. And so then I left my PhD program to work on this full-time. And then in July, we actually launched our software. And so I'll let my father introduce himself briefly.
Yeah, so I've been in the industry for a fairly long period of time. So I was, prior to this, I was EVP and CTO for iTech Corporation. That's a $900 million company, and they make base materials for printed circuit boards. Prior to that, I was with Shengi, which is a company out of China. And for a long period of time, I was at Isola, Allied Signal, and I was their CTO for Isola and helped develop a number of products there. So I've had a lot of experience with the PCB industry. And what I have from an educational standpoint is that I have advanced degrees in electrical engineering, a PhD in mechanical engineering, and a master's as well, and an MBA, of course. All these things together, and the whole idea was when Keshav and I talked about working on Avishtech, we kind of felt there was a need for this new software which would do things fundamentally different compared to what we had in there, because I'd seen those pain points firsthand. And to me, it was like, okay, why doesn't anyone try to solve this problem? And well, the biggest problem was because it required disciplines and knowledge and disciplines which you don't find. I mean, combination of electrical engineering, mechanical engineering, and material science. How do you do that? And somehow we had that expertise and we were able to knit it together and come up with this software. So it was a great opportunity in 2019-20 timeframe that we worked on it, and we launched it in July last year.
Well, I'm really excited with what you shared with me the other day when we had a chance to chat, and I could definitely see year two past converging. I've had some history with working with Roger Staconic, Isola, all those companies that you mentioned, Tarun, and modeling, the copper roughness, all those things obviously affect the performance and may or may not be easy to measure. There's a lot of variables there, right? So why don't we just jump right in there and talk about, Keshav, I'm going to toss this one over to you. Talk about an overview of the tools you offer, and then we'll dig in a little more about what makes some of your tools really unique.
Sure. What we offer are two products. So there's Gauss 2D, which is our 2D field solver for transmission lines. And our second product is Gauss Stack, which is a PCB stack up design and simulation tool. So what Gauss 2D does is it's a fully frequency dependent tool where you can get impedance, loss, RLGC, prop delay, all of the real signal integrity related properties that you're going to care about with your transmission lines. And where we saw the key opportunity with this that we saw for us to fill a need was in terms of loss modeling. That was the first key pain point that we identified for Gauss 2D to solve. And so a key issue there is that when you were operating in, say, the megahertz range, loss modeling was relatively straightforward because even if you've not accounted for certain effects, your results are going to be close enough for your purposes. Because at the end of the day, what you really need to know is this going to work for my loss requirements? Is this going to meet my loss budget or not? Your question is a binary. It's a yes or no. And so now as you go to higher and higher frequencies, especially if we're looking at 28 gigahertz for 112 gigabits per second per channel applications, or 77 to 81 gigahertz for automotive radar, now your loss budgets are very small, and the loss modeling becomes exceptionally important. And so one key effect that was that hasn't been accounted for in any of the existing tools prior to us launching Gauss is the effect of proximity, the proximity effect and the effect of ground plane losses. And so what that really is that when you get into these higher frequencies and when your dielectric thicknesses shrink, you end up with a secondary return path, and that creates additional losses.
Right.
And so one of the things we sought to solve was that, well, let's model this. Let's get an accurate simulation tool for insertion loss. And this has been a real pain point in the industry, because what happens is you use one of our competitive tools and you run that simulation, and it tells you, okay, you're going to meet your loss budget if you have a 0.7 dB per inch loss budget for your 40-inch line, trying to meet that 112 gigabits per second per channel. Mm-hmm. And your simulation shows that it was actually 0.65. You think, okay, so this is gonna do the trick. And then you go ahead, you build a test board, and you find out, oh, my loss is significantly higher than I thought it was. It's well above what I calculated, well above my budget. Mm-hmm. And you're actually seeing something that might be 0.82, 0.83. And so now you don't really know what to do. And your conclusion is either my copper numbers are wrong or my dielectric material numbers are wrong. When really the biggest problem was that, no, it's actually that your simulation tool was not accounting for a key effect. And so that's one thing that we sought to solve with Gauss 2D. And so it has a number of additional features. We developed this broadband extraction. So that's a first of its kind offering, where you can basically put in a set of S parameters, measured S parameters, input them, and our tool will extract over the full frequency range of your measurements, your DK and DF of your actual material, as well as the copper roughness. And it does so through we didn't expect to get the kind of accuracy that we eventually did, but basically we built a fairly sophisticated machine learning and enhanced physics-based algorithm for that. So that's one thing we do there. We also have things like we have a power handling calculation. So basically, for RF microstrips, you need to know how much power can this microstrip actually handle with it and stay within my operating temperature range. So we have that as a utility. Of course, S parameters, you can plot them, look at the full frequency dependent properties, export to touchstone. So really what we wanted to do there was create a tool that doesn't require you to build signal integrity test vehicles anymore, and to really try to eliminate that part of the process, so that all of the things that you really care about, you can find out virtually. And so that's what we've done with Gauss 2D, and with Gauss Stack. That's actually where we sought to solve an even broader issue, which really came down to, so sure, the way that the typical process works is you might just specify your stack up, you put in your prepregs and cores, and you just pick them based on what thickness you're looking for, and then you find out your pressed thickness. Now a lot of tools don't even provide that, but some of the more expensive tools that people will typically use will allow you to just calculate the pressed thickness, and then you use that to run your signal integrity simulations, right? But there are key issues that you're not able to predict with the incumbent solutions. You don't know, is this board actually going to be manufacturable, and is this board going to be reliable? And so a lot of times what we'll find is that you'll be going very deep into your design process, many months, and you'll discover a key problem. You'll discover that this board can't be built, and you don't know what's causing that issue. And so that's where we sought to offer the ability to predict glass stop, which is a key failure mode that leads to CAF problems, voiding, crazing, also warpage simulation. So what that does is, if you have an asymmetric stack up or a hybrid stack up, you're going to see warpage typically. And so if you have in your simulation tool in Gauss Stack the ability to predict that warpage, you can then iterate through to find out, okay, what do I need to change to make it work, right? To make it so that my warpage is minimal or maybe even non-existent. And then other things that we put in were, so initially our thought was that we can build these thermomechanical properties that you can extract that you can simulate for the board at the board level. And so you'll get your CTEs and moduli. And so that's really what we wanted to build something that can do all of this in terms of the reliability side, the manufacturability side, as well as in Gauss Stack, you can also do the signal integrity simulations. So that's on a broad level what we wanted to build.
So, Tarun, I want to ask you something about this. So I know a little bit about this in that I used to be heavily involved in RF and microwave bare printed circuit boards. So I remember having engineers come to me and saying, what I simulate and what you sent to me aren't the same. And kind of flying blind a little bit, like, why isn't, and from my end at that time being a fabricator, there's also things we could do inside of the shop that could screw them up, say if there was undercut traces, or there's a whole host of things. So in your mind, as someone with the materials background, how do you see that playing out and playing into that and those blind spots that people may not be aware of?
So yeah, I mean that's precisely what we and Keshav alluded to, that is that, if you take there's always been a lot of confusion about, I try to simulate it and it doesn't work, right? Losses are higher. I have other issues that I couldn't predict, and here we are staring at this problem. And in most cases, now what's happened over the years is that some of those things, those areas of uncertainty, have been blocked. Like for instance, now anyone who's concerned with signal integrity is not going to use rough copper. And now people have characterized it to the level that, it's okay. I'm going to use a copper with an RZ value of 2 microns. So that's what they're going to be doing. And so that's blocked up. So you don't have a lot of uncertainty on copper, for instance. In the past, microwave laminates used to have adhesion problems. So what they were doing was that they were making materials which were ultra low loss, but then you had copper, which was extremely rough because you wanted a good bond between the copper and the dielectric. And what that resulted in was you defeated the purpose, because for the microwave PCB manufacturer was overall insertion loss, not just the dielectric loss. So at least that's what was happening. So now there's been a lot more awareness in that regard, but still there's a lot of confusion which is coming in on dielectric properties now, because as it's as you're starting to block those areas of uncertainty, now you're coming to an area where you find out, well, I built this board and now I'm seeing a much higher loss, and it's got to be the dielectric. So you start disbelieving the numbers that are coming in from the material side, and you say, well, I don't believe it anymore. And that's where this software helps you plug those gaps. And what we did was we took a series of test data that came in, the actual test data. And we said, let's see if we just take the published numbers that are from the material suppliers. We take the published numbers from the copper suppliers and let's simulate it, okay? And then compare it to the actual results. And we got a very close match on 3 or 4 different materials and from different laminate manufacturers. And the fabrication, of course, was done. I think some of this was Lee's data that we looked at. And when we found that out, it was telling us that, people are building these test vehicles just to confirm, which could already be done with an accurate simulation software, right? So that was the issue that we were seeing, that you couldn't do that in the past. And now we plug that gap. And these are just published numbers, no fudge factors, no nothing. So it tells you that the data out there is not bad. What was missing was this calculation. If you're taking away 30 to 35% or even 40% of the loss, which is in the ground plane, then you're going to say, well, I'm going to throw it into the copper bucket, or I'm going to throw it into the oxide bucket, or I'm going to throw it into the dielectric bucket. And numbers don't vary that much. Dielectric measurements are not that bad. They've gotten a bad reputation, mainly because of this. So I think that gets addressed to a large extent with the software that we have.
Well, that's kind of earth-shattering. I remember working with Rogers and this disconnect of, and then it's, how do you measure? And how do we know it's true, where people were starting to really question those data sheets that they were publishing. So what I'm hearing you say, and Keshav, I'd like to hear from you on this, that this is one, plugging some gaps, but it's also a more holistic view. I want to insert right here that when Tarun just mentioned Lee, so these gentlemen have been working with Lee Ritchie, who never endorses a product, but he has endorsed the software because he's such a strong believer in it. So I think that's a really, really, that says a lot to me. And so Keshav, talk to us a little bit more about how you see this sort of holistically as opposed to pieces, and what kind of value that brings.
Absolutely, and yes, we're certainly very pleased to have gotten Lee Ritchie's endorsement, because we obviously, like most in the industry, we hold him in very high regard, and to see that he believes so strongly in what we're doing, and as strongly as we do. Basically, that's just great to see. And so, but to your point, that's exactly it. What we're trying to do is enable PCB designers, people working with transmission lines, to basically get the broadest picture possible. And so in one environment, in Gauss Stack, you have at your disposal the ability to find out all of these key failure modes and all of these key things that you care about. So you're able to find out, can I manufacture this board? You're able to run those predictions for plated through hole reliability. How many cycles to failure am I going to see in my service conditions? You can look at the same question for your microvias. You can look at that for solder joints. And you can specify any kind of conditions you'll be running into, and basically, barring manufacturing errors on the fab house shop floor, you will know, is this going to work? Am I going to be able to build this? Am I going to be able to ensure that this is going to meet the criteria I need for my service conditions? And so right now, the approach for solving a lot of these key problems is it's trial and error with multiple test boards and respins. And so basically what happens is you come up with, okay, so this seems like a good design. You make it in your, you put together a stack up, then you run some signal integrity simulations and say, okay, this sounds good. Let's go ahead and build a test board. And you build the test board, and you find, like I alluded to earlier about signal integrity, you find that doesn't quite track. Your loss numbers aren't the same. But more importantly, what you'll typically find is you might find that, okay, I'm seeing calf issues on this board. I'm seeing voiding issues. And so that's an indication of glass stop. Or rather, glass stop is the mode that in almost all cases is causing it. Right. And that's something you can predict in Gauss Stack. Oftentimes you'll build a test board and run it through an IST test or some other industry standard test for reliability. And you'll say, well, okay, I needed to get 1,000 cycles for these particular conditions. And I didn't meet that. But again, you don't have the granularity there necessarily. You don't know, did it fail at 990 cycles or did it fail at 200 cycles? And so what you get in terms of measurement, you get a lot of yes or no answers to questions, where you really need to get more granular data. And some kind of indication as to what you need to do to fix it. And so you're left with some rules of thumb. You're left with your intuition, having built a number of boards in the past. But unfortunately, that's just not possible to get it right the first time. Sometimes you might get lucky, but apart from that, there's nothing to guide you. And so that's what we've really created here, is so that you can take a look at all of these aspects in one go, and you can iterate through virtually. So it's virtual prototyping that we're allowing designers to do, so that they don't have to build a board redesign, build a board redesign. Rather, they just build one board maybe at the end for validation, and when they build that board, they're going to find, okay, this tracks with the simulations I ran in Gauss Stack, and the insertion loss, the S parameters, the frequency dependent properties all track with what I saw in Gauss 2D. And so that's what we've really tried to create here. And the feedback we've been receiving from customers has been very much consistent with this, where they've said, these were real problems that I didn't catch until very late into the design process. Certain things they caught 6 months in, or 12 months in, 18 months in. And it took them maybe an hour to find the problem in Gauss Stack. And often the fixes are not all that complex, but you don't necessarily know what they're going to be. And so you might have to try 4 or 5 different things in Gauss stack to fix your problem. But whereas that would actually have been 4 or 5 different test builds that you do.
Right, which is so darn expensive and so frustrating.
Yes, exactly.
And sometimes they're populating the board before it shows up.
Right.
And that's really expensive. And I can see some of the pain points based on what you've both said is blind spots, virtual prototyping, so much of this solves a lot of problems. So I'm very excited about it. So Tarun, can you talk a little bit more about some of the early feedback you've been getting? And also maybe, without naming names, maybe tell us about a use case in which you were seeing good results.
So yeah, the feedback has been, what we were initially concerned about was when we said we can do virtual prototyping. I mean, we were concerned that there were going to be questions, but the best way to build trust, as George Walk said, I believe in God, all others bring data, right? So that's the thing, that if you can get that data in front of the customers, then they start becoming believers. So we've had instances. There was one case where a customer came in and said, well, okay, they initially started off with a discussion on signal integrity, but then they said, well, we've got this. So you're saying you can do this? And we said, yes. So they gave us a set of problems, which they said, well, can you simulate that? And within like less than 10 hours, we were back to them, giving them not only the solutions. And again, some of those, like Keshav said, these people think that these are intuitive things, but simulations actually tell you that some of this is counterintuitive, right? So you have to literally work through that, and you can't do it in a real environment. So we came back and said, okay, these boards are going to warp and these boards are going to be fine. And when they look at it, they were kind of really dazzled with that. And then what they said was, well, now we'll have to run some experimentation based on your solutions. And just to let you know that validation is going to take 3 months. Okay, so it just tells you it takes 3 months to get the validation done for the solutions we talked about. So of course, once people do that and see that, that cuts away a huge amount of work, right? And like you said, the cost is humongous. So that's one pain point that we were really excited with that. In another case, this is again a major OEM, and when they heard that we could predict things like the CTEs of the package and all that, one of the engineers that said, well, that's huge. I could just take it and plug it into a spreadsheet and try to get some numbers. We said, no, you don't need to do that. Actually, Gauss Stack will do that for you. And you can just say, well, this is my process conditions. We went through that. So that's a huge company doing a lot of reliability work and signal integrity work. And so they're really pleased with it. And then there was one instance where it was like they came back and said, wish we had this, because they were 18 months into, they did the work. They found out what was a good solution for the signal integrity. And then they went out there and they started building boards. And
that's
they found
amazing.
out
18 months.
18 months, yes.
That is a glowing report.
Yeah, and they were really pleased with that. But also, I felt bad that they had to go through this, and now it's like their whole confidence is shaken on the material side because they've done this, and they find out it's not working because they've got voids and other issues. And so that's the validation that we've received so far, and the feedback from the customers. There's a lot of especially on the reliability side, because when you do that and you can find out, well, this is what this product's going to do, and tell me in advance a priori, then it takes away all this iterative process, which is extremely expensive. So that's what our value proposition is, that you don't need to do it, and you can just run through those simulations. And our customers are using it nonstop. I was surprised to see that one of the person's primary responsibility is not doing stack-ups, is actually using them using this tool on a daily basis. So that's really good validation to hear.
So two things. So Keshav, maybe you can talk for a moment
Mhm.
on ease of use, and then perhaps tell us where you're going next. I'm sure you have some other things on the back burner, and whatever you can share. I'd be like for our listeners to know maybe what they can expect to see further coming out of Avishtech, because this is really exciting stuff.
Sure. As far as ease of use goes, that really was something that we felt was of paramount importance, because in our experience, what we've seen is that you can come across a certain simulation software, design software, and it makes some claims about what you can do with it. And oftentimes when you ask for a trial, you start working with it, and you realize you don't necessarily have the time to figure all of this out, because there's just so much you have to do just to run a basic case in it, just to get started with it. And so we didn't want to be another tool just like that, because uh, what that does is that, I mean, I'm sure there are a lot of tools out there that have provided some meaningful improvement that don't necessarily resonate with people, simply because people aren't able to figure them out, and it's just too much work to get started. And even a lot of our competition, that's one of the issues, is that you need to have a very high degree of familiarity with the software. And every time you come back to it, you need to relearn a few things. And so we wanted to take a fundamentally different approach with that. And so we designed it so that you don't need to understand anything about the software. You don't need to understand about the methods we're using. All you need to do is make a few key selections, and it's we've laid everything out so that it basically guides you through just as your eye moves. That's where you go step 1, 2, 3. You just select all of the things directly from within the tool. So in Gauss 2D, you basically select what your configuration is. You put in your dielectric heights and widths, all of the things that it prompts you for. And you just click a button, you click the analyze button, and you get your simulation results. It's that easy. And even with all of our post-processing, or with synthesis, where we actually flip the problem so that you can get line widths for a target impedance. Even with that, it's again very simple. Click of a button, and you just get a small little pop-up with a couple more inputs that you have to put in. And so really we designed that to be very straightforward to use, while providing you with the highest accuracy and all of the properties that you care about. And we applied that same philosophy to Gauss stack. And so you don't need to do anything complicated. You just have to specify how many layers you have, it takes care of constructing that for you, and it just asks you, okay, so why don't you tell me what prepregs you want? And so you go in, you just use our integrated library, and you just with a few clicks, you've selected all of your prepregs, all of your cores, and you specify what your copper layers are, and you're set. Now you click the compute button, you get all of those thermomechanical prediction. You run the thermomechanical simulation, you get your press thickness, the glass stop checks, all of that with just one click of a button. You can do for the signal integrity, you can do the analysis for the entire board with one click. For both analysis and, again, synthesis is available in Gauss stack as well. And even with the reliability predictions, all you have to do is just a few clicks and you're there. And so we really designed this that in such a way that we thought, well, if we put in a little bit of extra effort, or in some cases a lot more extra effort, but basically if we put in the effort, we take it on, that we create each individual scenario, and you just have to select them rather than having to create them. That makes things a lot easier. And so That's why we went in and built this integrated library in Gauss Stack. That's why we have all the predefined geometries in Gauss 2D. And so we really emphasize ease of use, and that's paramount. And all of the feedback that we've gotten has dovetailed with that perfectly. That, a lot of people who obviously have used other tools had virtually no adjustment to using our tool. And even people who hadn't been using stack up tools or field solvers in the past, they were able to get started with almost no friction. And so that's been great to see. Now, to your second point about some of the things that we have in the pipeline, obviously we have a lot of exciting things that we're working on, some features that we'll probably be announcing fairly soon about additional functionality. But one of the things that we are really excited about that we can talk about is we're we're expanding our offering in that we're going to have this accessible through our website on an as needed per use kind of a basis. So there, a lot of customers who may have a need for what we're doing, but they're not, but maybe they're not working with many stack ups or many different designs.
Yeah, maybe they do 3 layouts a year, right? And they
exactly
don't want to buy, an on-premise thing that they only use 3 times a year. So it'll be cloud-based then, and like a subscription type model, or how would that work?
So the model that we're going for is basically, so it'll be a per use kind of a model. So if you just want, and we'll have we will be having the full menu of what services you want, and some of those will be services that also you can talk to us. If you want to have a meeting with us, need to understand something, that's also part of that offering. They can reach out to us, and it's so we've designed it to not be impersonal either. So if somebody if somebody needs some help, somebody needs to figure certain things out, we're available to assist with that. But yes, it's going to be, we're going to have cloud-based. We're going to have an application that allows you to create your stack ups. And if you prefer, you can actually send them to us in whatever format you have them, and that'd be again another add-on there. But basically, if you want to have say a particular type of simulation done, you just select what are the things that what are the results that you want. What is it that you're looking for? And so all of the capabilities of Gauss Stack and Gauss 2D will be available as individual one-time use options on the web. And so that's something that we're really excited about, because it, like you said, some of these shops who might only be working with 3 layouts a year, they still care about those. They still want to make sure that those boards work. But maybe it's not appropriate for them to have a full-fledged on-premise license. Right. And so this would be a way for them to get on board, and also it would be quicker, because they don't necessarily have to go through the process of figuring things out, of getting familiar. Even though it is very easy to use, it just reduces friction even further. Right. So that's what we're going for there.
And,
well, go ahead, Tarun.
Yeah. So, and the other thing is that we have a dimensional shrinkage model, which we don't offer in our standard version. So that'll be available, so people can pick up their stack ups and say, well, I want to find out. So that's again a pain point in the industry, that shrinkage, you can't predict it. Well, if you have misregistration, then you're going to end up with scrap, right? And that's something that people don't want. And that's why they run scout lots. And that's a painful process, that somebody wants a quick turn of 24 hours. You're going to take those 24 hours just to run a scout lot, right? So that you find out. So that's that we've done validations on that. So that's going to be a part of our cloud offering, is where you can come in and you may have one stack up, or you may have 10, and then we'll have a tiered pricing model for them, so that if they want 100 of those a year, or 10,000 of these for the whole corporate, then we can just work it out. But then we also want to think about that user out there who just has 1 or 2 or 3 of these, and they can come in and do this. So the dimensional shrinkage that happens, and it's a major problem, it's a major pain point for the industry, that gets addressed also with our offering over here. And then on top of that, we are still going to look for making it more powerful in the terms of doing certain other predictions, figuring out, for instance, warpage, which we talked about at the board level, but what happens at the semiconductor level, right? When you're doing chip packaging, that's a huge problem. So that's also on the anvil. And it's, again, using the same basics, right? So that's what we're going to do, is now we're just replacing the board with a chip on top, and then you have a board which is going to be used for chip packaging. So that's what we're looking at as well. So expanding it beyond the PCB users, because the use case is the same, it's just a different customer, right? So why not extend it to them?
Well, you guys, I'm such a fan, even more so than I was with our initial conversation, because the way that I sort of look at my role at Altium and in the industry is I want to advocate for removing pain points. And I think you guys have just annihilated some really painful ones. And I think it's going to be a game changer. And having use cases and then people with the weight of Lee Ritchie getting behind it, I think you're really onto something. So I want to say congratulations and best of luck going forward.
Thank you.
Thank you.
Thank you so much, Judy.
It's been a joy to have you. So for our listeners, if you want to learn more about Avishtech, I'm going to put their website link in the show notes below. And also, they did a webinar, and I'm going to attach the link there. But I would go right now and go check out their website. I think you're going to be really excited about it. And I hope you've enjoyed this podcast. Thank you, gentlemen, again for joining me today. I hope we stay in touch and you keep me up to speed.
Absolutely, Judy. Thanks for having us.
Thanks, Judy. Thank you.
Thank you. I'm also going to put Keshav and Tarun's LinkedIn profile. They're lovely guys. I'm sure they'll be happy to answer any questions. So their LinkedIn profiles will also be below. Thank you to our listeners for tuning in this week. We'll see you next week. Until then, remember to stay healthy, stay safe, and always remember to stay on track.